Imagine standing on a beach at midnight, watching waves roll in from a dark sea. Now imagine someone tells you the sea isn't there. The waves are real. You can measure them, surf them, drown in them. But the water? The water was never there at all. For more than 200 years, from Huygens to Maxwell, some of the greatest minds in physics filled the universe with an invisible ocean. By the 19th century, it had a name, the luminiferous ether, the light-bearing ether, and it had become the mainstream physics of light. And here's the part nobody tells you. They weren't fools. Believing in the ether was a thoroughly rational position for a scientist to hold. The evidence pointed to it, right up until the night the ocean vanished. Welcome to Sketches of Never, where we visit the world that made sense at the time. This is the story of how physics lost an ocean. Let's start with why anyone would believe in an invisible ocean in the first place. In 1801, a British polymath named Thomas Young did something deceptively simple. He shone light through two narrow slits onto a screen. If light were made of particles, you'd expect two bright bands. Instead, Young saw stripes, a whole zebra pattern of light and dark. This is exactly what waves do. Drop two stones in a pond and watch the ripples cross. Where crest meets crest, the water leaps. Where crest meets trough, it goes still. Light was interfering with itself. Light was a wave. But a wave of what? Think about every wave you've ever met. Ocean waves are moving water. Sound waves are vibrating air. That's why in space, no one can hear you scream. A wave isn't a thing. It's a behavior, a shimmy passing through some substance. At least every wave physicist had ever known worked that way. Light seemed to be the one exception, so they assumed it wasn't an exception at all. If light is a wave, and light crosses the void from the sun to your face every morning, then the void cannot be empty. Something must be there, doing the waving. That something needed remarkable properties. Light moves fast, about 300,000 kilometers every second, and the stiffer the medium, the faster its waves. So the ether had to be more rigid than steel, yet the Earth plows through it at 30 kilometers a second without slowing down, so it also had to be thinner than any gas, offering no resistance at all. Rigid as steel, thin as nothing, filling all of space, invisible, silent, everywhere. I know how that sounds, but be honest about the alternative. Waves made of nothing, waving through nothing. To a 19th century physicist, that wasn't just wrong, it was gibberish, like applause without hands. And then the ether got its greatest champion. In the 1860s, the Scottish physicist James Clerk Maxwell wrote down 4 equations tying electricity and magnetism into a single force. Out of the mathematics fell a prediction: electromagnetic waves, traveling at exactly the speed of light. Light wasn't just any wave, it was a ripple of electricity and magnetism itself. Maxwell's theory was the crowning achievement of the century's physics, and Maxwell himself described light as vibrations of the ether. The invisible ocean wasn't a fudge on the edge of science. Radio, electric motors, the entire coming electrical age, all of it built on equations whose author believed they described the physics of the ether. So by the 1880s, the ether wasn't a hypothesis anymore. It was the stage the whole universe performed on. Only one embarrassing detail remained. Nobody had ever detected it directly. And one man in Cleveland, Ohio, decided to fix that. Albert Michelson was arguably the finest experimental physicist alive, a man obsessed with measuring light more precisely than anyone in history. His logic was beautiful. The Earth orbits the sun at 30 kilometers per second. If space is filled with ether, then from our moving planet there should be an ether wind, the same way you feel a breeze on a bicycle even on a still day. Light traveling into that wind should move a whisker slower than light traveling across it. A whisker. The difference would be about 1 part in 100 million. At the detector, a shift of less than half of 1 interference fringe. Measuring it was like timing 2 sprinters and catching a gap of a single atom's width. So Michelson built a machine of almost absurd delicacy. The interferometer, a beam of light split in 2, sent down 2 perpendicular arms, bounced off mirrors, and recombined, so that the tiniest difference in travel time would show up as shifting stripes of interference, the same zebra pattern Young had seen. The whole apparatus sat on a massive sandstone slab, floating on a pool of liquid mercury in a closed basement, so that a footstep, a passing cart, even warm air couldn't disturb it. To take a reading, Michelson and his collaborator Edward Morley walked slow circles around the tank, watching the stripes as the device rotated through the supposed wind. In the summer of 1887, they ran the experiment. Rotate, measure, wait, rotate again. Different times of day, different months, the Earth pointing different directions as it swung around the sun. The result? Nothing. No shift. No wind. Whichever way they turned the apparatus, light moved at exactly the same speed. It has been called the most famous failed experiment in the history of science, unfairly, because the experiment worked perfectly. It was the hypothesis that failed. Physicists call it a null result, and this particular nothing turned out to be one of the most important measurements ever made. The ocean refused to appear. Now, here's what the textbooks skip. Physics did not calmly close the book on the ether. That's not how belief works, not even scientific belief. Instead, the best minds in Europe spent nearly 20 years rescuing it. The Irish physicist George Fitzgerald and the Dutch physicist Hendrik Lorentz proposed something wild. Maybe motion through the ether physically squeezes objects, shrinking Michelson's apparatus in the direction of travel by precisely the amount needed to hide the wind. The math worked. It always worked. That was the eerie thing to its critics. The ether seemed patchable forever, because each patch was designed to be unmeasurable. And to be fair to Lorentz, his theory was no desperate fix. For years it stood as a serious rival to what came next, and its equations were correct. The ocean was still there, the argument went. It had simply arranged, down to the last decimal place, to be undetectable. If that sounds suspicious to you, congratulations. You're thinking like a young patent clerk in Bern, Switzerland. In 1905, Albert Einstein published a paper on the electrodynamics of moving bodies. Where everyone else asked, why can't we find the ether? Einstein asked a more dangerous question. What if we take the experiments at face value? What if light simply moves at the same speed for every observer? No wind, no medium, no exceptions. He rebuilt physics from that single stubborn fact, and the introduction of an ether, he noted, was superfluous. The word is almost cruel. 2 centuries of the substance of the universe, superfluous. The price of dropping the ether was steep. Space and time themselves stopped being absolute. Moving clocks tick slower. Moving objects contract. Lorentz's equations were right, but not because an ocean squeezed them. There was no stage beneath the universe. There was only the performance. And the ether believers. Lorentz, one of the giants, never fully let it go. He and Einstein remained friends and mutual admirers, 2 honest men standing on opposite shores of a vanished sea. Michelson received the Nobel Prize in 1907, the first American to win in the sciences, honored for the precision of his instruments. The very instruments that had measured his beloved ether out of existence. He reportedly regretted it to the end, still fond of the ocean his own hands had erased. So what does the ether leave us, besides a cautionary tale? More than you'd think. Every part of the story was good science. The ether was a reasonable inference from real evidence. The experiment that killed it was designed by believers trying to confirm it. The rescue attempts produced the very mathematics relativity was built from. Being wrong, carefully and honestly, is how physics moves. The ether wasn't a wrong turn on the road to truth. It was the road. And one last thing to keep you up tonight. Modern physics says the vacuum isn't empty after all. It seethes with quantum fields, and space itself can stretch, ripple, and carry gravitational waves. Nobody calls it the ether, and it isn't one. The universe turned out stranger than either side imagined. But if you could sit Maxwell down and tell him that empty space has structure, energy, and physics of its own, he might just smile. The ocean he believed in was never there. The emptiness just turned out to be less empty than anyone dreamed. What do you believe today that's rigid as steel and thin as nothing? Tell me in the comments. This has been Sketches of Never. The ocean was never there. But for 200 years, it was the most reasonable thing in the world.